Hello, ladies and gentlemen of Algebra 2. Welcome to the beginning of the last unit of Algebra 2A. It's a very short unit, and it's just looking at a couple of concepts that should come up in geometry, just kind of reviewing the big ideas and kind of helping you to remember kind of how all this kind of comes together. So, Pythagorean theorem, you've seen it before, you've used it before. You might remember that it's just a squared plus b squared equals c squared, but you might not remember kind of every little minute detail about it. So here's kind of where it came from. A guy named Pythagoras found an amazing fact about triangles. A triangle at a right angle, which made it a right triangle, and he made a square on each of the three sides. Then the biggest square had the exact same area as the other two squares put together, resulting in what we know as a squared plus b squared equals c squared. Now, Pythagoras was not the only one to prove this. There's been about 20 to 30 different proofs of this. They're all looking a little bit different. So I'll leave that to you when you're really, really bored sometime to look that up. So here's kind of what we're looking at. Please note you want answers in radical form, not decimal form, okay? No decimals. I want it in simplified radical form, which is this. Don't get lazy and put a decimal. You will be wrong. So for number one, 6 squared plus 15 squared equals x squared. So that's 36 plus 225 equals x squared. So that'll be, let's see, 261 equals x squared. So to solve, I want to take the square root of 261, which is not a perfect square. So I'm going to have to simplify a square root of 261. So what I start doing then is I start trying to divide by things that are perfect squares. So I want to try and divide by 4, 9, 16, things like that. And I figured out that 261 can be split into 9 and 29. So I take the square root of 9 times the square root of 29, which is just going to be 3 square root of 29. So there's my answer. There's my simplified answer, 3 square root of 29. So for number 2, same idea. 7 squared plus 17 squared equals x squared. So that's 49 plus 17 squared, I lose 190 or 289. 289. So that's going to be 338 equals x squared. So when I square root of 338. So now I got to start playing around a little bit. Divide by 4, divide by 9, see if anything's going to work. And if I actually divide this by 2, I get 169 and 2. Square root of 169 is 13. So there's my answer, 13 square root of 2. So for number 3, change colors here so not to get confused. 11 is my hypotenuse, so it goes x squared plus 9 squared equals 11 squared. So that means x squared plus 81 equals 121. Now I got to do a little math, so it's 40, a little algebra. So I've got to break up 40. That can break up into square root of 4, square root of 10. So that's going to be 2 square root of 10. There's my answer. Now I need simplified square roots, not decimals. Decimals don't help me. Decimals are ugly and they don't give me a good idea of what I'm dealing with. So don't get in that habit of giving me decimal answers. So Damon is locked out of his house with the only open window on the second floor, 12 feet above the ground. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from the house to avoid shrubs, what length of ladder does Damon need? So he's got 12 feet to clear. He's got to be back 5 feet to avoid the shrubbery. How long does this ladder have to be? Well, I'm going to figure this out. 5 squared plus 12 squared equals c squared. So that's going to be 25 plus 144 equals c squared. So that's going to be 916c squared. So if I square root that, I'm going to get 13. So the ladder should be at least 13 feet. Okay, 13 feet would be perfect just because I would be able to match it right up to the window. So Pythagorean triples are exactly what it sounds like. They are three whole numbers that work perfectly in Pythagorean theorem. So the simplest one's 3, 4, 5, 5, 12, 13, 7, 24, 25. And then here's kind of the pattern to remember. All the multiples of 3, 4, 5, 5, 12, 13, 7, 24, 25 also work. So if 3, 4, 5 works, 6, 8, and 10 work. 9, 12, and 15 work. 12, 16, and 20 work. Okay, so this is all these, multiplied by 2, multiplied by 3, multiplied by 4. All those multiples work. So here, 10, 24, 26. Multiplied by 3, 15, 36, 39. Those are all Pythagorean triples. Again, whole numbers that work in Pythagorean theorem. So if I keep going, 3, 2, 3, 4, so it'd be 20, 48, 13 times 4 is going to be 52. All these are common Pythagorean triples. Now, you don't have to memorize them, but, just you get enough practice with it, you can start to kind of recognize it when it shows up. So, you go 14, 48, 50. You see, you go 21, 72, 75. All right, this is getting a little ridiculous. But just kind of the big idea, these are the common three, and then all their multiples also work. So if I take this, figure out my value of x, okay, hopefully you recognize that this does me no good. So I'm going to go x squared plus 10 squared equals 14 squared. So then I'm going to go x squared plus 100 equals 196. So x squared equals 96. X is going to equal square root of 96. Don't give me a decimal answer. 96 divided by 3 is 32. 96 divided by, hey, you know what? 96 divided by 16 is 6. And I know 16 is a perfect square root. That's going to be 4. So my answer is going to be 4 square root of 6. So if I look here, this one's going to get a little trickier. X squared plus square root of 2 squared equals x plus 1 squared. Let's change colors just so we don't screw anything up. So that's going to be x squared. Square root of 2 squared is just going to be 2. This is going to be x squared plus 2x plus 1. Now, where did the 2x come from? Well, here's what everybody loves to forget. This is really x plus 1 times x plus 1. So if I take this, x squared, that's going to be x, that's going to be x, that's going to be 1. I add these two, that's going to be x squared plus 2x plus 1. A lot of kids will see this, and they'll give me an answer of x squared plus 1 and think that's your answer. No, there's going to be a middle term, so that's where this comes from. So now it's coming to solving. So if you're worried about the x squared, don't worry because it goes away. Bam, bam. So 2 equals 2x plus 1. So subtract 1. So hopefully you get an answer of 1/2. So there's my answer, 1/2 for that problem. All right, so you're going to try out the rest. Couple things to remember: area of a triangle, area of a rectangle, perimeter. And you're going to do that. And welcome to the last unit. Let me know how I can help, and have a good day.